Welcome to Math by McCaw. In this video, we will solve problems about fractions. We recommend you to stop the video after every question and try to solve it by yourself before revealing the answer. We will begin with easy questions and proceed on to harder ones. If the first questions are too easy for you, please skip until you find your level. Let's review a few details about notations first. These are the symbols we are using today for multiplication and division. And this is how we are going to represent the fractions. We may switch from one to the other. Finally, this is how we are going to read the fractions. For example, this fraction can be read as 3/7 or as 3/7. If you are ready, let's begin. What is 5/7 of 273? This is one of the most basic questions about fractions. Here, we are given 273 wholes. And, by taking 5/7 of it, we divide it to 7 equal pieces and take 5 of these pieces. 273 divided by 7 is 39. 39 divided by 5 is 195. Or, you can simply multiply our number by given fraction. It is actually same chain of operations. We've reached the same result. The only thing we need to remember is that every integer can be written as a rational number, like 273 is 273/1. Also, as we've learned, while multiplying fractions, we multiply their numerators and denominators separately and take the resulting numbers as our new numerator and denominator, respectively. There are 25 girls and 20 boys in the class. What part of the class are girls? If we want to find the ratio of girls to the whole class, first we need to find how many students in total. 20 plus 25 equals to 45. Here, we have 45 students and we select 25 of them. So, our denominator is 45 and our numerator is 25. Hence, the ratio of girls is 25/45. We need to simplify this fraction. We know that every integer that ends with 0 or 5 can be divided by 5. So, both 25 and 45 can be divided by 5. So, there are two options we can choose. We can divide them by 5 and try to move on from there. Or, we can set up division schema. Here 3 only divides 45. And again, it divides only 15. 5 divides both. So this is one of the factors of the greatest common divisor, GCD, of them. Now, 5 divides only 5 and we've reached the end. Since the only factor for GCD is 5, it is the GCD of 25 and 45. To simplify the fraction, we just divide both numerator and denominator by their greatest common divisor, in this case, 5. 25 divided by 5 is 5. 45 divided by 5 is 9. So, our simplified fraction is 5/9. If we wanted to find the ratio of girls to boys, then we would choose our denominator as 20, and our numerator as 25, 25/20. And, if we simplified it, we would get 5/4. As you see, there is no integer that divides both 5 and 4 except 1, 5/4 is simplified. There are 8 apples, 10 oranges and 12 bananas in a basket. Find the fraction of the bananas. There are 8 plus 10 plus 12 equals 30 pieces in our basket. It means that our denominator is 30. Since we take only the bananas, we take 12 pieces. So, our numerator is 12. Our fraction is 12/30. Even at first glance, we can see that this is not a simplified fraction. Both the numerator and denominator ends with an even number, so they both can be divided by 2. If we don't want to set up dividing schema, we can list the divisors of each number and find the multiplication of those that repeat in each list. The list of divisors of 12 is 2, 2, 3. The list of divisors of 30 is 2, 3, 5. The commons are 2 and 3. So, their greatest common divisor, GCD, is 2 times 3 equals 6. We need to simplify our fraction by dividing both the numerator and denominator by their GCD, 6. And, so, our simplified fraction is 2/5. There are 55 shirts in a shop. 24 of them are white, 20 of them are blue and the rest is green. What is the percentage of the green shirts? First, let's find out how many of the shirts are green. The number of shirts of the other colors, 24 plus 20 equals 44. The number of the green shirts, 55 to 44 equals 11. Since there are 55 shirts in total, our denominator is 55. And, we pick 11 of them, so, our numerator is 11. So, our fraction is 11 over 55. Here, it is hard to see but this fraction isn't in its simplest form. We need to find the greatest common divisor of the numerator and denominator and simplify our fraction accordingly. Let's set up the dividing schema. 5 only divides 55. 11 divides both and the division ends. So, 11 is our GCD. So, we need to simplify our fraction by dividing both the numerator and denominator by 11. And we get 1/5. The percentage problems belong to a different topic, but today we will mention briefly. If we have a fraction and we want to turn it into a percentage, all we need to do is to expand or simplify the denominator to be 100. Since our denominator is 5, and 100 divided by 5 is 20, all we need to do is to expand our fraction by 20 and we get 20 over 100. Here, we were lucky that 100 can be divided by 5. If that were not the case, we would have to play with it a little. For example, if our denominator were 40, we would have to divide it by 2 then multiply by 5 to get 100. Our expanded fraction 20 over 100 gives us the percentage, 20% of the shirts are green. Sally had 81 euros. She spent 1/3 of her money on books. How much money was left? There are a few ways to solve this problem. First, we can calculate how much money she spent. If we take 1/3 of 81, we get 27. Since she had 81 euros in the beginning and then spent 27 euros, now she has 81 minus 27 equals to 54 euros. Second, we can begin by calculating the fraction of the money that was left. In the beginning she had a whole and then she spent 1/3 of it, so now she has 2/3 of it. And this equals to 54 euros. A grandfather gives 5/24 of his books to his granddaughter, Cecilia, and 9/19 of his books to his grandniece, Mary, and 7/36 of them to his grandson Archie. Who's got more books? As you've noticed, in this question, we haven't been given any number. So, we need to compare the fractions, instead. So, let's find out which has the greatest value among 5 over 24, 9 over 19 and 7 over 36. Since they all have different denominators, we can't compare them directly. First, we need to expand these fractions so that their denominators would be the same. Let's set up our dividing schema and find their least common multiple. Here, we need to take all the factors into the multiplication and we get our LCM as 1368. 1368 divided by 24 is 57. 1368 divided by 19 is 72. 1368 divided by 26 is 38. So, we need to expand 5 over 24 by 57, 9 over 19 by 72, 7 over 36 by 38. And we get 285 over 1368, 648 over 1368 and 266 over 1368. Now, we can compare them. Whichever has the greater numerator, has also greater value. In this case, 9 over 19 is the greatest and 5 over 24 is the middle and 7 over 36 is the smallest. So, his grandniece, Mary, has got more books. What is 1/3 of 7 over 24 of 144? We've seen that if we want to find a fraction of a number, we simply multiply the number by the fraction. It is the same for the fractions. If we want to find a fraction of a fraction, we simply multiply them. So, 1/3 of 7 over 24 is 7 over 72. And 7 over 72 of 144 is 14. As you see, while multiplying we can switch the orders. We can divide by the denominator first, and then multiply by the numerator. It is done to make the calculation faster. Mel has 400 cherries. He gives 3/8 of them to Sophie and 2/5 of the rest to Chad. How many cherries have left? We have to be careful here that Mel didn't give 2 over 5 of all of his cherries to Chad. He gave 2 over 5 of the remaining cherries. 5 over 8 of them was left. So, he gave 2 over 5 of 5 over 8, 2 over 8. Let's add the fractions that he gave to Sophie and Chad. We get 5 over 8. So, the left of cherries as in the form of fraction is 3 over 8. Finally, we need to find 3 over 8 of 400, and that is 150. Paula spends 1/3 of her salary for the rent, 1/8 of it for food and 1/5 of it for utilities. If she gets left with €1,230, what is her salary? Let's find out how much Paula spends in total, 1/3 plus 1/8 plus 1/5. As their denominator are all different, we can't add them directly. We need to find their LCM, least common multiple, and expand each, accordingly. The least common multiple of 3 and 5 and 8 is 120. If we expand the fractions accordingly, we get 40 over 120 plus 15 over 120 plus 24 over 120, and it equals to 79 over 120. Now we need to find out how much is left. Since there is one whole in the beginning, we subtract 79 over 120 from 1 and get 41 over 120. We need to be careful here. 1,230 is the amount that has left. So, if we call the whole salary as A, we get 41 times A over 120 equals to 1,230. We need to cross-multiply it by taking the denominator of 1,230 as 1. So we get 41 times A equals to 1,230 times 120. We can simplify 41 and 1,230 by 41, and find that A equals to 30 times 120, and that is 3,600. At a fundraising dinner, the number of women is 6 plus 4 times of the number of men. If there are 96 people in total, how many of them are women? Let's call the number of men as X, so X equals to the number of men at the fundraising. Since the number of women is 6 plus 4 times of men, it is 4x plus 6. As there are 96 people in total, x plus 4x plus 6 is 96. If 5x is 90, we need to divide 90 by 5 to find x. So we find x, the number of men, as 18. In this case, the number of women is 4 times x plus 6 equals to 78. 3 over 7 of a barrel is filled with water. If we take 1/3 of the water, we need 30 liters to fill it to the brim. In this case, how many liters can this barrel take? First, let's find out how much water we take. Here, we need to be careful. The water we are taking is 1/3 of the current amount, 3 over 7 of the barrel. To find 1/3 of 3/7, we multiply them and get 1/7. And to find out how much is left, we subtract this amount from the initial amount and find that, currently, 2 over 7 of the barrel is full. If 2/7 of the barrel is full, we need to 5 over 7 more to fill it up. And, since this ratio equals to 30 liters, we need to divide 30 by 5/7 to find out the capacity of the barrel. And we get 42 liters. There are 41 people in a bus. If 2 women and 4 men leaves, the number of female passengers becomes 2/5 of the number of male passengers. How many female passengers had the bus in the first place? First we need to find how many people there are left after 2 women and 4 men left, so we subtract 6 from 41 and get 35. If 2/5 of them are male, we multiply 35 by it to find the number of men, and get 14. 35 minus 14 equals to the number of women left, which is 21. But to find the initial number we need to add 2, and find that there were 23 female passengers in the beginning. 1/6 of a number plus 5 equals to 1/3 of the same number minus 20. What is this number? Let's call this number x, so we get x times 1/6 plus 5 equals to x times 1/3 minus 20. This means x over 6 plus 5 equals to x over 3 minus 20. We can take 5's and 20's denominators as 1, and try to find a common denominator for each sides of the equality. When we add the fractions on both sides, we get that x plus 30 over 6 equals to x minus 60 over 3. Here, we need to cross-multiply. So, we get 3 times x plus 90 equals to 6 times x minus 360. Remember, when a number switches across the equality, it changes its sign. So we get 6 times x minus 3 times x equals to 360 plus 90. And we get x as minus 150. After being dropped, a ball can bounce back 1/3 of the original height of drop. If it bounced 24 centimeters up after hitting the ground for 3 times, what was the height that it was dropped in the first place? Let's call x the height it was dropped then. For the first time, it bounces x over 3. For the second time, it bounces x over 9. For the third time, it bounces x over 27. Since this equals to 24, we get x as 27 times 24, which is 648 centimeters. Congratulations! You have reached the end of this topic. See you soon.